Welcome to second part of lecture number 2 of engineering drawing and graphics for engineer. So in first part of this lecture we have introduced the scale which is one of the most important topic of engineering drawing, and we have discussed the different types and the conversion of scale into representative fraction. Now in this second part of lecture number 2 we will discuss the types of scale. Okay, see, whenever you prepare the drawing of an object or the drawing of a structure or any mechanical component, then in the title block you have to express or you have to represent the scale of that drawing, that what is the relationship of dimension of the drawing with the actual dimension of the object or structure or component. Okay, so for that representation we have three types of scale. Either we have to represent it as a engineer scale, or we have to represent it graphically, or we have to write here the representative fraction of that scale. Okay, so see, as we have discussed that the engineer scale is easy, that the dimension of the drawing is equal to the actual dimension. Okay, that is the engineer scale. For example, if 100-meter object is drawn is 10 centimeter, then the engineer scale will be 10 centimeter is equal to 100 meter. Okay, this is the engineer scale. This is also one of the representation, and also we can represent it as a we can say that we can represent it as a representative fraction. Okay, for example, in 1 meter we have 100 centimeter, so the representative fraction will be 1/1000, or it can be written as 1:1000. So this is the representative fraction. So these two are the numerical or analytical expression or representation of scale. So as we have discussed that with respect to the time, or when the map or plane become older, then the map, the drawing will become shrink, and this engineer scale or the representative fraction will not give the actual proportion of the drawing dimension to the actual dimension. So in that case we are recommending, being an engineer, the graphical scale is recommended, that you have to draw the scale graphically. Okay, so in this second part of the lecture we will discuss the graphical types of the scale. Okay, that how you will draw, how you will construct the different graphical scale in a sheet of paper. Okay, so see, scale in the drawing, as we have also discussed that when an unusual scale is used, it is constructed on the drawing sheet. To construct a scale, the following information is essential. Okay, so whenever you are constructing a graphical scale, so these things will be required: the representative fraction of the scale. Okay, see, whenever you are drawing an object or structure or mechanical component, so obviously either you will have to enlarge the dimension, or you will have to reduce the dimension. And remember, the each and every dimension will be reduced or enlarged by equal proportion. Okay, suppose if you are drawing the rectangle, okay, so it has two dimensions, length and width. Okay, so for example, the actual width is 100 centimeter, and you have drawn it as 10 centimeter. Okay, in the drawing, suppose in the drawing you have drawn it 10 centimeter and actual is 100 centimeter. Okay, so the proportion is, if you look into it, it is 1:10. Mean 10 times you have reduced the width of this rectangle. Similarly, for example, the length is 200 centimeter, so you have to drawn it as 20 centimeter, so its ratio will be also 1:10. So you can see that the length and width are equally reduced. Okay, so that is the thing, that whenever you are drawing the objects either in larger scale or in reduced scale, so each and every dimension will be reduced by a constant proportion. Okay, So when you are constructing the graphical scale, so first you have to know about the representative fraction of the scale. You will have to know about the units which it must represent. That whenever you are drawing a scale, graphical scale, so you must have to know that what is the unit, either it is in metric system or it is in FPS system. Okay, what either it is suppose meter and centimeter, or it is for example kilometer or meter, or it is miles. Okay, in FPS system you will have inches, you will have feet, or you will have yard. Okay, so the unit must be given. The maximum length which it must show. See, for each and every drawing we will have some limited graphical scale, okay, through which we can take the dimension from the drawing. So that will be given that how much maximum possible length you have to transform from the drawing into actual dimension. So the maximum length of the scale will be given. And see, then whenever you are drawing the graphical scale, so how much line will be drawn? So that is equal to the representative fraction multiplied by the maximum length which you want to measure. Okay, see, for example, if you have the drawing of an object, and for example here you are constructing the graphical scale. Okay, so the length of this graphical scale is representing that this much distance can be transformed into actual dimension at one time. Mean at a time you can transform this much distance from the drawing into the actual dimension. So that is actually the length of the scale, and that will be depend on your requirement, that how much maximum distance you want to transform from the drawing into actual dimension at one time. Okay, so the maximum length will be given, the representative fraction will be given. So the representative fraction multiplied by maximum length which you want to measure, which you want to transfer, so that will be equal to the length of the scale. So then you will have to draw this much distance. Okay, we will discuss it furtherly in example. So we have different types of the graphical scale. One is the plane scale, the diagonal scale, comparative scale, vernier scale, and scale of chords. So at this level we will discuss the construction of plane scale and diagonal scale, that how you will graphically construct the plane scale and diagonal scale whenever you are drawing an object or structure. Okay, so we will discuss one by one. So the first one is the plane scale. So see, if somewhere or if in maps you have seen such type of thing, such type of representation, so that is just called the plane scale. Okay, a plane scale consists of a line. Okay, we have just sample, we have a line, and that is divided into suitable number of equal part. See, now we have this line, and this line is divided majorly into two parts. One part is this one, and second part is this one. Okay, and again the first part is divided into sub part, or it is divided into smaller part. Here you can see that this first part is divided into two parts, and then this first part is divided again into we can say that almost two parts. Okay, so see, maximally through this scale we can convert 200 units, and minimally we can convert up to 20 units. So see, for example, if here we have the unit is kilometer. Okay, so it means that, for example, if you have a drawing of an object, okay, and suppose this much distance you take it the drawing, suppose from this point to this point, for example, this distance is equal to this much distance. So the dimension of this drawing will be equal to 200 kilometer of the actual dimension. Okay, and for example, if you take this distance, so through divider we are transferring these dimension, that for example, if you take this distance and suppose it is equal to this one, so this much distance at the drawing will be equal to 20 kilometer of the actual dimension. Okay, so in every scale, first the 0 will be placed at the starting point. Remember, these are just the rules or recommendation of the plane scale. The 0 will be placed at the end of first division between the units and its subdivision. From the 0 mark, unit should be numbered to the right and its subdivision to the left. Okay, and the name of the unit and the subdivision should be stated clearly. Mean the name of the unit, that how much is the unit at this side and what is the unit of the right side, and the name of the scale. Okay, here you will have also to represent the representative fraction. You will have to write the representative fraction of the scale. That must be mentioned. Okay, now let's solve the different example from the book of engineering drawing of Andy Butt 53rd edition. Okay, so the first problem is construct a scale of 1:4 to show centimeter and long enough to measure up to 5 decimeter. Now see, at the start we have discussed that we will have different requirement, that the representative fraction will be given and the maximum length that will be given. So see, we have to construct such a scale through which we can measure 5 decimeter distance, through which we have to transform this much distance from the drawing into the actual dimension. Okay, so see, if you have a sheet of paper, suppose this is the border line. For example, here you have drawn your required structure. Now here you will have to construct the graphical scale. Here you will have to construct the plane scale. And see, this drawing is drawn through this representative fraction. Mean the object is reduced 4th time from the actual dimension. Okay, so first of all, you have to find out that how much line will be drawn. Mean the length of the scale. So length of the scale is equal to the representative fraction multiplied by the maximum length which you want to measure. So that is given, which is 5 decimeter. Okay, so 1/4 multiplied by 5 decimeter multiplied by there are 10 centimeter in 1 decimeter. Okay, in 1 decimeter we have 10 centimeter. So if you solve it, so 5 tens are 50 and divide by 12, so you will get 5 tens are 50 divided by 4, so you will get 12.5 centimeter. Okay, now remember that you have to draw a line of 12.5 centimeter. Just draw a line of 12.5 centimeter long and see, divide it into 5 equal part. See, 1, 2, 3, 4 and 5. Okay, just draw a 5 centimeter line, 12.5 centimeter line, that is the length of the scale, and equally divide it in 5 parts. So see, this 12.5 centimeter line on the sheet is representing 5 decimeter actual dimension. Okay, now here you can see that this one part will represent 1 decimeter. If in the drawing you have this much distance, so in reality it will be equal to what? 1 decimeter, or it will be equal to what? 10 centimeter. Okay, so just write here 0, 1, 2, 3, 4 and 1 to this side. Okay, and then furtherly you can divide the first part. Okay, furtherly divide this part into 10 parts. See, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So see, this one part, if in the drawing if in the sheet of paper you have this much distance, it will be equal to 1 centimeter of the actual dimension. Okay, so then you can make it furtherly more attractive and more visible. So just draw another line. Okay, just join it. Now this is just for the we can say that for the sake of clarity, or for the we can say that for the sake of more attractiveness. Okay, and at the center you can draw another line. Okay, just shade this portion and shade this one, also shade this portion. Okay, so it will be just looking more visible or more clear. Okay, here you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mean this is 1 decimeter or 10 centimeter, because 1 decimeter is equal to 10 centimeter. Okay, so see, and right here that at this side that is representing decimeter, and at this side it is representing centimeter, and below the scale just write the representative fraction, that the representative fraction is 1/4. Okay, so that is just a plain scale which we have constructed. Okay, now second example is draw a scale of 1:60 to show meter and decimeter. We have two units, we have to represent the meter and decimeter. So decimeter is a subunit of meter. See, in 1 meter we have 10 decimeter. Okay, and the scale will be long enough to measure up to 6 meter. We have to construct a scale of such a length through which we can transform the 6 meter distance from the drawing into the actual object. Okay, so the first step is just determine the length of the scale. So the length of the scale will be equal to the representative fraction multiplied by maximum length. Okay, so 6 meter. Now we can say that there are 100 centimeter in 1 meter. So meter will be cancelled. 6 multiplied by 100, that will be 600, divided by 60, so you will get what? 10 centimeter. Now you can see that if you draw a scale of 10 centimeter, it will be equal to 6 meter distance. Okay, so just draw a line of 10 centimeter. Second step is draw a line of 10 centimeter and divide this line into 6 equal part. See, 1, 2, 3, 4, 5 and 6. I'm just dividing it roughly. You can divide it through divider in equal part. Remember, divide the line in equal part. And also in next lecture, in third part of this lecture, we will also explain the graphical method, that how a line can be divided into equal parts. But you can also use the rulers, or you can use the divider, but the standard method is the graphical method, that how a line can be divided into equal part, any number of equal part. So see, the first step is just determine the length of the scale. Second step is draw a line of 10 centimeter. Third step is divide that 10 centimeter line into 6 equal part. Now see, one part will represent 1 meter, because 10 centimeter is representing 6 meter. So we have divided this in 6 parts, so one part will represent what? 1 meter. Right here 0, 1, 2, 3, 4 and 5. Okay, see, 5 meter is that one and 5 meter is to the left side. Now see, that is 1 meter. Okay, so furtherly divide this part into 10 equal part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So see, this 1 meter is divided into 10 part. So it means that this one part will represent 1 decimeter. This is 2 decimeter, 3, 4 decimeter, 5, 6 decimeter, 7. This is 8, 9 and 10 decimeter. Mean 1 meter distance is divided into 10 equal part. So it means that this one portion will represent 1 decimeter. Okay, so if in a drawing, suppose you have this much distance, so in reality this will be equal to 1 decimeter. Yeah, in a drawing, if you have this much distance, so in reality it will be equal to 2 meter distance. Okay, and just to distinguish the division clearly, we are drawing here another line. Okay, and see, just for the more clear visualization, you can make some portion of the line, we can say that you can shade it. Okay, so just draw another center line. So here you will have the we can say that you can shade this portion alternatively up and down. Okay, alternatively you can shade it, so it will be more clear. Yeah, it will be we can say that more clearly visible, or the parts will be more clearly distinguishable. So you can shade the alternate part of the scale. So at this side that is decimeter, at this side that is meter, and here you can write the representative fraction, which is 1:60. So this is the required, we can say that this is the required plane scale. Okay, okay, now we have example problem 4.3. Construct a scale of 1.5 inch is equal to 1 foot to show inches and long enough to measure up to 4 feet. Okay, so see, the engineer scale is given. First convert it into representative fraction. So 1 inch in the drawing is equal to 1 feet in reality. So we know that in 1 feet we have 12 inches. Okay, so unit will be cancelled with each other. 1.5 divided by 12, so we will have 1.5 divided by 12, we will have 1/8. So this is the representative fraction. Okay, now the length of the scale is equal to representative fraction multiplied by the maximum length. So the maximum length which we want to measure is 4 feet. Okay, and in 1 feet we have 12 inches. Yeah, there are 12 inches in 1 feet, so feet will be cancelled. And now you can see that 4 multiplied by 12 divide by 8. 4 multiplied by 12 divide by 8, so that is 6 inches. Okay, so now just draw a line of 6 inch. Okay, divide it into 4 parts, 1, 2, 3 and 4. Okay, it means that 6 inch distance on the sheet will be equal to 4 feet distance in actuality. Okay, so if we draw a 6 inch line and divide it into 4 parts, so one part will represent how much distance? 1 feet distance. Okay, so right here 0, 1, 2, 3 and 1 is this portion. I mean this is 1 feet portion. Okay, and now you can divide it into 12 equal part. Mean this is 1 feet distance, divide it into 12 part, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and suppose 12. Okay, I'm just roughly dividing it. You can actually divide it through divider or scale or the graphical method, which will be discussed in next lecture, that how you can divide a line in equal part. So just divide this portion in 12 equal part. Okay, so see, this one part will represent what? 1 inch. So if in a drawing you have this much distance, in reality it will be 1 inch distance. Okay, so here you can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this side is representing inches and this side is representing feet. Okay, and for more clear and visual representation of the scale, just draw these two horizontal line. Okay, just shade this portion, shade here the upper portion. Okay, and you can shade this portion similarly, just solidly shade this portion, mean alternatively one up and one down, just for the clear visualization. And the representative fraction, right here the representative fraction, which is 1/8. So that is the required plane scale. Construct a scale of representative fraction 1/60 to read yard and feet and long enough to measure 5 yard. So see, the representative fraction is given, maximum distance is given. So just find out the length of the scale, which is equal to 1/60 multiplied by 5 yard. Okay, multiply the representative fraction with the maximum distance. So 1/60 multiplied by 5 yard, and see, in 1 yard, we have 36 inches. In 1 yard we have 36 inches are there in 1 yard. So yard will be cancelled with yard. 36 multiplied by 5 divided by 60. 36 multiplied by 5 divided by 60. So you will get 3 inches. Okay, because 36 multiplied by 5 is 180 divided by 63 inches. So just draw a line of 3 inches. Now see, 3 inches in the drawing is equal to 5 yard in reality, in actuality. See, actual dimension is 5 yard. Then in the drawing you have to draw 3 inch. Okay, so draw a 3 inch line, divide it into 5 equal part. Okay, so one part will represent 1 yard. So right here at the end of first division 0, 1, 2, 3, and 4. Okay, and see, in 1 yard we have 36 inches, or in 1 yard we have 3 feet. And in the question that is given that we have to represent yard and feet. So divide the first part into 3 equal part. So this will represent 1 feet distance. Mean this is 1 feet, this is 2 feet, and this is 3 feet. 3 feet mean 1 yard. Okay, so right here the unit feet, and right here the unit yard. Okay, and write the representative fraction below the scale, which is 1/60. And for more visualization, just draw the horizontal line and draw here one horizontal line. Okay, just shade this alternatively. Okay, you can properly draw it by using different drawing instrument, so then it is more clear and more easily observable. Okay, and see, now for example, if someone want to take the dimension of suppose 3 yard and 2 feet. Okay, so see, from this point, 1 yard, 2 yard, 3 yard, 1 feet, and 2 feet. So see, if in the drawing you have this much distance, so in reality it will be equal to 3 yard and 2 feet. This is also the representation of the we can say that of the dimensions. Okay, next example is Construct a scale of representative fraction, this one, to show miles and furlongs. Remember, in 1 mile we have 8 furlong, okay, and in 1 mile also we have 1609 meter. Okay, this is just the unit conversion. Now the representative fraction is given, the maximum length is given, and we have to represent the mile and furlong in the scale. Okay, so just find out the length of the scale, which will be equal to the representative fraction 1/84480 multiplied by the maximum length, which is 6 mile. Now we know that there are 1609 meter in 1 mile, or there are 100 centimeter in 1 meter. So meter will be cancelled, mile will be cancelled. Now when you just simplify it, okay, when you just simplify it, so you will get that for example, suppose I'm taking just a rough value, suppose that is 10 centimeter. Okay, so just draw that 10 centimeter line, divide it into 6 equal part, 1 2 3 4 5 and 6. Okay, we have drawn the 10 centimeter line and divided it into 6 miles and divided into 6 parts. So one part, okay, so this one part will represent 1 mile. Okay, so here you can write it here 0 1 2 3 4 and 5, and see we have to represent per long, so this is 1 mile, so divide it into 8 part, 1 2 3 4 5 6 7 and 8. So this one portion will represent furlong, 1 2 3 4 5 6 7 8. Okay, so this is the furlong portion, and to the right side from this 0, these are the miles. So here write down the unit mile and write down here unit furlong, and mention the representative fraction, which is 1/844 and 80. Okay, and also you can draw the central horizontal line, and you can shade the alternative portion, okay, for more and better visualization. Okay, so this was all about the plane scale. Thank you. If you have any question, if you have any comments or concerns, you can ask through comments. And the lecture is continued. In third part of this lecture, we will discuss the diagonal scale. Thank you.